Mr. Gopi, what about your department students? Did you inform them?
Yes, Father.
Okay, you can just send a reminder.
Okay.
Then. Yeah. Okay, then. Good. Maybe Kusum, Mr. Kusum.
Yes, Father. Yes, Father.
You can.
The classes. The library. The science lab.
Sir, you are not audible. Hello? Sir, you are not audible.
The generator.
Good morning, dear participants. We are going to begin very soon. I welcome all of you with us in the St. Xavier's family at Maharo.
Hello, Himadri, can you hear me?
Yes, sir.
Am I audible?
Yes, sir.
Okay,
Perfect.
thank you.
Yes, sir. Thank you, sir. Welcome, sir.
And miss
Copy. Good morning, Copy.
strong pillars for his.
So rational thinking that if you have certain problems or the
St. Xavier's College is a timely venture of the Dumka Raiganj province. The classes. The library. The science lab. The generator.
Good morning, everyone. Himatri sir,
Yes, sir.
we can start the session. I had just a talk with the Honorable Vice Chancellor Madam, and she
Okay,
said that
sir.
she will be joining by her time.
Okay, she will be joining later.
No, she will be joining at her time only.
Okay, sure. So we can begin then?
Yeah, we will begin.
Okay, sir, sure. Okay, I think Father has left. Let him join, then we can begin. I think maybe network issues. Okay, so I welcome all the participants wholeheartedly once again from our St. Xavier's family at Maharo. And we are beginning, and before we begin, there is a very earnest request to all the participants that we are expected to follow the netiquette rules. As you know, that is, we are expected to keep our video and audio in mute, and during the question answer session we can unmute ourselves if we have any questions. So that is a request before we begin. So we can begin then, Amresh sir.
Yes, sir. Father is also there. We can start the
Sure. Okay. So I welcome all of you. A very warm and very hearty good morning to all the participants from our St. Xavier's family at Maharo here in Dumka. I hope and I pray that all of you are keeping safe and fine in this very adverse times. So before we begin, let me welcome all of you once again. The Internal Quality Assurance Cell, that is the IQAC of St. Xavier's College, Maharo, is organizing a national level webinar, that is a web seminar, on a very interesting topic, as you have seen from the brochure itself. It is titled Chemistry, a Wide Area of Research. Very interesting topic, and especially for emerging scholars who are pursuing their research in chemical sciences especially. And I am very certain this will open up new spectrums of knowledge and critical insights into the subject and beyond. So I welcome you all. On this occasion, we are very fortunate and blessed to have our Honorable Vice Chancellor Madam of Sidhu Kanu Murmu University, Professor Dr. Sona Jharia Minj, who is joining us very soon. So, Madam has been very kind to consent to be with us amidst a very busy schedule. We are very privileged to have with us our respected principal of the institution, Reverend Father Dr. Stephen Raj, who is also the patron of this webinar. We also have with us the IQAC coordinator of the college, Reverend Dr. Father David Raj. I welcome you, Father, wholeheartedly on this platform. We are indeed very privileged and honored to have with us our chief speaker of the day of this webinar, Dr. Virendra Singh, Associate Professor at the Central University of Punjab. Sir has very kindly consented to be with us and enlighten us on such a very immense scholarly topic. I welcome you wholeheartedly on behalf of St. Xavier's family, sir. I welcome all our noble participants once again from the core of my heart. Your precious presence is going to dignify this occasion all the more. So without any further delay on my part, I invite our principal and also the patron of this webinar, Reverend Father Dr. Stephen Raj, for his keynote address. Father, please.
Thank you. Am I audible?
Yes, Father.
Yes.
Okay, thank you. Honorable Vice Chancellor of Sidhu Kanu Murmu University, Dr. Sona Jharia Minj, eminent officials from Sidhu Kanu Murmu University, all constituent and affiliated college professors, research scholars, students, and other participants. A very good morning to you all. It is a great honor and privilege for me to address the distinguished participants of the national webinar on the topic, Chemistry, a Wide Area of Research. On behalf of the management, Father Nirmal Raj, the Secretary, Father David Raj, the IQAC Coordinator, and all our faculty members of St. Xavier's College, I welcome you all. Today's webinar is very significant and essential for all of us. Chemistry is important because everything we do is chemistry. Our body is made up of chemicals. One can easily observe this branch of science in different spheres of human life, such as the food we eat, the air we breathe in, the various cleansing agents we use. So much so that even human emotions are sometimes a result of chemical reactions within our body. Research in this subject of chemistry will help us to solve many present and future problems like sustainable energy, food production, managing our environment, providing safe drinking water, and promoting human and environmental health. I am sure that today's webinar titled Chemistry, a Wide Area of Research will be an interesting and inspiring one. The eminent speaker of the day, Dr. Virender Singh, Department of Chemistry, Central University of Punjab, will enlighten us on the topic and create a profound interest in all of us on the subject chemistry. I take this wonderful opportunity to thank our faculty, Mr. Gopinath Gorai, the head of the chemistry department and convener of the webinar, Mr. Amresh Bose from B.Sc department and co-convener of this webinar, Mr. Kushum Kannan Mishra, the head of the BBA department, Mr. Himadri Shekhar from the Department of English for organizing. I wish the seminar will be a great positive and will create a positive impact on all of us. Thank you. God bless us all.
Thank you very much, Father, for the keynote address. Your words of encouragement and appreciation has raised up our spirit very immensely. We will proceed with our session. Just let me add with pleasure that Honorable Vice Chancellor Madam has joined us. I welcome Ma'am from the entire family of St. Xavier's. We are indeed very, very privileged and blessed to have you within us. So on behalf of St. Xavier's, I welcome wholeheartedly, Ma'am.
Welcome, ma'am.
Okay. So with utmost pleasure on my part, I now invite the IQAC coordinator of our college, Reverend Father Dr. David Raj, to invoke the blessings of Lord Almighty for a successful and fruitful webinar today. Over to you, Father.
Thank you. Am I audible, sir?
Yes, Father. Yes.
Okay.
Audible. Yes. Sir.
Respected Ma'am, Dr. Xavier, the Honorable Vice Chancellor of SKM University, I wholeheartedly, with folded hands, welcome you, ma'am. And it's a great privilege having you amidst us. Ma'am will be delivering the keynote address shortly. And we are privileged to have Dr. Virender Singh, sir, the Associate Professor of Central University of Punjab, Bhatinda. The guest speaker of today, sir, is going to enlighten us with the various different areas of knowledge in chemistry. Reverend Father Dr. Stephen Raj, S.J., the principal of St. Xavier's College, Dumka, Maharo, and the patron of this seminar. Mr. Himadri Datta, the Assistant Professor of English Department. Mr. Gopinath Gorai, the Head of the Department of Chemistry. Mr. Amresh Bose, the HOD of Computer Department. Mr. Kusum Mishra, the HOD of the Business Administration Department of St. Xavier's College, Maharo, Dumka, and all the dignitaries from around the place, and all the eminent scholars and research scholars, professors from our neighboring colleges. It's a great privilege to have you all amidst us in this evening, in this morning of a beautiful day, to share our ideas and also get enriched by this webinar. At the beginning of this webinar, I pray to the Almighty God for His blessings upon each one of us, that the seminar, the webinar goes smoothly and all of us go enriched by this. May God bless all of us. Thank you very much for giving an opportunity to me in this manner. And I now invite respected Ma'am Dr. Sonajharya Minj, the Honorable Vice Chancellor of SKMU, for her keynote address. Ma'am, over to you. Over to you, ma'am.
Johar and good morning to all. Honorable Principal, Dr. Stephen Raj, Dr. David Raj, the IQAC Director in charge, the esteemed invited speaker for this conference, and all the participants, colleagues from probably chemistry department and other science faculty. It is an honor for me to be connected with the conference this morning with you. Of course, in the capacity of being the VC of the university, University. But also as a teacher. Basically, I have, of the 30 years of my career, I started research before that. I mean, before that, for towards my degree, and thereafter for my bread and butter, in another sense. But today, as the chemistry department has decided to take the lead in organizing this webinar-based seminar, and these days we also hear the term AIR Meet, virtual conference, and terms such as that. I mean, I have a bit of problem with the term virtual conference, because the conference is actually happening. It's a virtual platform. Virtual for the reason we are not meeting in person in one place and interacting in person. Has got other threats in comparison to when we have a conference such as that. So it's a platform which is virtual. Maybe AIR Meet is a better term, but then the conference is actually actual. It's not virtual in that sense. And it's again not a strange thing that the chemistry department has taken the lead of trying to organize a national webinar, and the theme being chemistry, a wide area of research. I think chemistry to each one of us must have been more real before we started studying it as a subject. I need to apologize. Unlike my style, I don't have a presentation today because my laptop has decided to not cooperate with me, and I'm using another system in my office in order to connect with you. Whereas I would have liked to have at least a slide or two displayed in order to keep my thoughts also focused, rather than they tend to go haywire. And coming back to the phrase I was talking about, I mean, chemistry could have been more real and realistic to most of us who studied it as a subject later in school and maybe in college also. Because I think we did notice some of the activities which later on in the subject of chemistry we get to demystify. So there must have been observations in real life and realistic terms, when probably some of us women and some of our male colleagues, participants who are here, must have noticed how sugar or salt is soluble in a medium such as which is liquid, and etc. And I mean, texture of various material and how they differ because they are of various and different elements and things like that. So maybe we didn't learn the subject, or we were not exposed to the subject in very, very technical fineries. But then I think the chemistry, the area such as chemistry, is an area which of course as a subject I didn't like so much, but then I was able to always score more marks in chemistry than in physics, which I liked better between the two subjects. And so, my recollection goes back to, if anything I have to remember about chemistry, and then things which I did not study even before I was introduced to the subject of chemistry was about Madame Curie, and how I did read a little bit about her, and I was wondering, what she kept doing, and about her discovery of radium, and I was so mesmerized by the work she did, and then how her work contributed to this entire area. And so, I think chemistry is one subject which, to my mind, because I'm a trained mathematician and again teaching of computer science, I feel chemistry is one subject which does enable a person to enhance expertise in specific, very, very specific areas of chemistry, but to any aam aadmi, any person, it is again a subject which is good enough to generate adequate curiosity. And so, while it can, as I was talking about how sugar is soluble, and sugar has a crystal, and we find it in crystalline forms and various, granularity, size of the granule and things like that. So we get to observe a lot of, the aspects and the areas and components of chemistry even before we get to study it as a subject. And so, we have this term called people science. Likewise, I think some maybe teachers from school or teachers teaching in colleges such as St. Xavier's, etc., could also take a time off during summer vacation or some vacation time, and just to enthuse young children and to attract them to these peculiarities, which later on are demystified and explained through the study of chemistry. I think we could take some time off to talk about people's chemistry, you see, where the children who may develop certain curiosities, they would go to the next level of curiosity. But those who do not, those who haven't developed curiosity also would be able to observe certain things, which chemistry does explain or demystify, as I said later. And but then where does the research component come? I think research, as if we take the lexical part of the word research, if we truncate the prefix, which is RE, then it is the word with search, right? So if I do the breaking up of this word, it's a one-word research, and I'm not a language scientist, and I don't have the right to do that. But if I, take the prefix, make re as a prefix to the word search, I think it could begin with the search part, right? And the enthusiasm, curiosity, or observations, if they add to the corpora of knowledge, a child by, even before the formal introduction of the subject of chemistry, is able to gather, this entire knowledge corpora, which comes through just observation. It may not be a keen search, but just manage to observe, and so that it could lead the person, one never knows, as to how many more curious and seemingly mysterious reactions or actions, we know when we study chemistry, then we will say chemical reaction, right? And then the formula or the expressions denote how certain part of each chemical component gets, decomposed and recomposed and etc. in order to compose a new substance or component. Yeah. So compound. I'm sorry. Compound. So I think as it has been envisaged in the seminar, that chemistry, I assume that this is what is envisaged, that chemistry has, the area of chemistry has unlimited. So when I say this word unlimited, I really mean it has unlimited scope of doing research, but then my condition is provided the researcher was curious enough after observing certain phenomena, certain actions and reactions in real life early enough before even being introduced to the subject called chemistry. And then so that sequence of observation and keenness to observe could continue and could be fostered in school and later on in college, so that the interest in the specific area, I mean, I can only go up to saying, organic chemistry and inorganic chemistry and etc., and then get into, specific aspect that somebody goes to a scientist in a petrochemical organization, or somebody else could go to BAC, and and somebody else can be just a teacher in St. Xavier's College, because the subject was so interesting to the person, and wanted to pass on that enthusiasm, the excitement to younger students. And so it to me, like any other subject, or to me like mathematics, which is supposed to repel many than attract, or unlike a subject like mathematics, which is made to sound like a ghost which nobody has seen, but everybody believes it exists. Like mathematics, for mathematics also, people do have this bias. It is a subject nobody can conquer. I don't think it's that way. I think I need to talk to such a lot. But then chemistry has a natural opportunity to attract younger minds and even make the young adults more curious minds, and to be attracted to specific areas which can lead to fine research and their contribution in areas which mean a lot. And especially now that we are talking about, we may not know why and the way it has so from now. Well, chemistry may not be all there, but then to contribute to things which matter to humans, environment, probably our natural resources, the use of plastic, the use of material which may be used for the carpet, or maybe curtain, or the interior decoration, and which through experiments and a lot of discovery in probably research in chemistry, these materials have been innovated and this have been composed, but do they add to the damage or destruction humankind has done to this earth, in which we are here only temporarily, right? So whatever is lifespan for each one. And so I think I wish research in chemistry would also deliberate on some of the ethical aspects as to what kind of research should be refrained from, and even if we do it, we know to set the boundaries for the use and not a misuse of those materials, those compounds, and so on and so forth. And so with this note, I would like to wish the one-day conference over the digital platform on the web. Very success. Each participant to end with a note of a lot of excitement, because we have an eminent speaker who I'm sure would be able to enhance the level of curiosity in the young people who are going to be the participants in this conference, and even the old ones who may just be sitting and listening because it's our duty. But then each of such conferences are always an occasion to enhance our knowledge, and knowledge when power must also give us the prudence, or we should also come with the prudence how to use the knowledge or even these discoveries. And so with these words, I would like to close, thanking the organizers for taking up the step to organize and making use of technology in such times of COVID, when physical gathering is not possible. On the digital platform it is possible, and to utilize our time more productively, and to do a lot of value addition to this entire process of education, and especially contributing to the knowledge corpora within the scope of Sidhu-Kanu Murmu University. So I want to once again congratulate the organizers. I want to wish all the very best to all the participants, and I would like to thank the invited speaker for agreeing to have come and be part of this conference, a national conference. Thank you very much, and Johar.
Thank you very much, ma'am. Respected ma'am, Dr. Sona Jarya Minj, the Honorable Vice Chancellor of SKMU, for your keynote address. You have only ignited our mind today, and you have set the spark glowing in all the young minds around us. And with this, I'm sure that they are going to take a great lead and great leap into research. Your connection, you also have spoken in your keynote address, ma'am, your connection with the subject chemistry, personal experience, and your connectivity and the connectivity of chemistry with the our subjects which we normally deal with. And also you have very beautifully connected it with our normal regular lifestyle of today. How this subject could be connected to other subjects in research, and also how it could lead us to further for the better future. Ma'am, as I told you, you have already ignited our mind. We are only waiting for the spark to get aglow. And thank you very much for being with us. Despite your heavy schedule, ma'am, we understand you've got a very busy schedule. Despite all this, having been with us, it was a great privilege and honor for us. Thank you very much. God bless you, ma'am. Thank you very much. Over to Mr. Himadri for further proceedings.
Okay, thank you, Father. Thank you, Honorable Vice Chancellor, Madam, for your address. We now come to the core part of this webinar, for which we all have been waiting very eagerly to hear our speaker of the day. So before I hand over the mic to Dr. Virendra, allow me to give a short introduction about Sir. Dr. Virender Singh is Associate Professor of Chemistry in the School of Basic and Applied Sciences at Central University of Punjab, Bhatinda. He has a wide teaching experience ranging over the last 2 decades, throughout which he has been very active in academic and research. His areas of specializations and research interests are in organic synthesis, medicinal chemistry, natural products chemistry, and green chemistry. Sir has more than 50 publications in books, magazines, and journals of international standard and recognition. He has also been peer reviewer and editor of several journals of acclaim. He has participated and presented research papers in innumerable national and international seminars and conferences. Several PhD programs and dissertations are ongoing and have been completed under his supervision. Dr. Singh has been a recipient of many professional awards, scholarships, and recognition at the academic level. So we are indeed very privileged to have such a very highly acclaimed and scholarly academician in our midst today. So without any further delay, I welcome you, sir. I hand over the stage to you, Dr. Virendra, sir.
Thank you, Himadri. Can you hear me?
Yes, yes.
Yes, sir.
We
Yes,
can
sir.
hear.
Thank you, Himadri, for such a nice introduction. At the outset, I would like to thank all the members of organizing committee, and starting from your honorable Vice Chancellor, Professor Minch, members of organizing committee, Father Dr. S. Stephen Raj, Father S. David Raj, Mr. Gorei, Gopinath Gorei, Mr. Amresh Kushum, and Mr. Himadri, and the whole St. Xavier family. I am very, very thankful to all of you for giving me opportunity to interact with you amid this COVID-19, and providing me opportunity to share with you, to talk with you on chemistry. Okay, thank you so much for giving me this opportunity. So my presentation is basically related to chemistry, some various fields of chemistry where research scholar or MSc student after their PhD, they can join, they can work. Then I have discussed to some extent the role of chemistry in day-to-day life. Then we will be discussing about how drug discovery take place, how drug discovery and development, how a molecule from bench to goes to the market. Okay, how it becomes a medicine and the various steps involved in it. Hope you will be find it interesting. Let me start it. I'm not able to share it to you. There's some problem. You must grant permission in order to screen share. Sir, please give me permission to share.
Amrishar? Amrishar? Can you just...
Sir, yes, sir, there is one tab over there, present now. From there you can go, from there you can share your screen. Present now option is there, just beside the turn on caption.
Sir, it is showing that you cannot share your screen. You must grant permission in order to screen share.
No such means options is there for a year. Okay, on your behalf, I am sharing your screen from here.
Please share, sir.
Okay. Okay. Sir, is it visible?
No, sir.
No, it's coming. It's coming. It's coming, sir. It's coming.
Yes, sir.
Is it visible?
Yes.
Coming.
It's coming.
Make it full screen.
Just a minute. It's okay?
No, it is very small in size.
Dr. Singh,
Yes,
I think for the viewers, it's quite big. I mean, considerably big enough to view. Maybe in your screen it's coming a bit smaller.
Sir, it is already visible in a large screen.
Yeah, it's visible. It's visible completely. Yeah. Amrishar, maybe you can coordinate with the speaker. I think maybe he's finding it small.
So it is very small in size. Yeah. हरमन, किसी को कंप्यूटर सेंटर से बुला के लाना, एक बारी थोड़ा प्रॉब्लम आ रही है. Sir, let us change it. By meantime, I have called someone to help me. Let us change the next slide. Okay. Sir, next slide is not coming. Yes, Gopi. Hello.
Yes, yes, sir. Is it okay?
अच्छा, ओके, मैं फिर से ट्राई करता हूँ. ठीक है, ठीक है. Sir, I am trying again. Okay. So it is saying that you must grant permission in order to share your screen. I need permission from your end, I think. Your entire screen.
Okay, sir, I'm sharing the screen. Let's see whether it is visible or not.
Gopi sir, can you share?
Yeah, I'm sharing. Let's see it's visible or not.
Okay, okay.
Okay, sir, are you using a Mac? Mr.
No, sir.
Okay.
Sir, let me. I was using Mozilla. Let me try at Google Chrome.
Yeah, it should work.
Okay, sir, try it with Google Chrome.
हैं? आ रहे हैं ना? अच्छा. Sir, I'm sorry for inconvenience, but
It's okay, sir.
sir, hello.
Yes, sir.
Yes, sir.
Allow me to share this screen, na?
So just click on present now. Let's see.
It is showing your screen, I think. Allow me to share the screen.
No, sir, it's the problem of your browser. So if you will use Google Chrome, it will work definitely.
Sir, because
now
actually Google Meet does not have any permission sort of thing, sir.
Yes, they're
There is
asking from your computer to give permission to share your screen. So if you will use Google Chrome, there won't be problem. I just Googled this problem, and the people, those who are using Firefox or Internet Explorer, they are having this problem. So if you will switch your browser, it should work.
or else, sir, we can do one thing. I am sharing your screen. You can go through that also.
I'm sharing, sir. Let's
Yes,
see
sir.
how
Your
it's
screen.
bigger.
Yes, it is visible, sir.
Yes,
Professor, it is visible.
Now
Okay.
it is visible, but okay. So the title of my let us start how it works. Okay, the title of my talk is an overview of research in chemistry, drug development and drug discovery. Okay, next slide, please. Okay, the content of my presentation involve the chemistry and its subdiscipline, role of chemistry in medicine and healthcare, chemistry in daily life, use of NMR and XRD in structural biology, application of nanotechnology, and then the real part of presentation will be drug discovery and development. Next slide, please. Okay, chemistry is basically a science of matter, as all of you know, and it involves the chemical reactions where various reactants react with each other in presence of a catalyst or some activator, and a product is formed. केमिस्ट्री इज कंसर्न विद द एटम्स. सर मेरी तरफ से स्क्रीन शेयर नहीं हो रही है, प्लीज देखना एक बार. सर एक बार आप बंद कर दीजिए उधर से, मैं इधर से ट्राई करता हूं स्क्रीन शेयर करने का. हाँ देखो ये प्रेजेंटेशन मैंने खोल रखी है यहाँ पे. Okay, now you can see my screen. Hello.
Yes.
Yes, sir. Yes, sir. It is presenting. Yes.
Okay, thank you, sir. Okay. Next, various subdisciplines of the chemistry. These are the major disciplines of the chemistry. Chemistry is a very wide subject, and each of these subdiscipline have further disciplines, further narrow areas where lot of research is going on. Okay, first of all, organic chemistry, that is the most vibrant area of vibrant discipline of chemistry. In organic chemistry, you can research in the area of organic synthesis, that is have huge scope in pharmaceutical industry. You can synthesize new drug molecules, biologically active molecules. You can synthesize organic sensors, and so many materials. We have huge application. Okay, then it is inorganic chemistry, where you study the inorganic materials, coordination compounds, coordination complexes, which have so many application as biomedical materials and as drugs. In physical chemistry, you study the various physical phenomena, physical reactions. And biochemistry is the discipline where you study the chemistry of biomolecules, chemistry of proteins, chemistry of DNA, RNA, their functions, chemistry of enzymes, how they act in the biological system. Then material chemistry deals with the chemistry of organic, inorganic, and other kind of composite materials. Analytical chemistry is basically the quantitative or qualitative estimation of various constituents of a material. Then in nuclear chemistry involve the chemistry of nucleus, how radioactive materials emit radiations, or how radioactive materials can be used for biomedical applications. Even nuclear chemistry also deals with the devastating field of chemistry, where nuclear materials are synthesized, nuclear bombs are synthesized, which produce lot of energy in positive, which can be used in a positive way as well as in a negative way. Then most important part is medicinal chemistry, where the fruitful part of chemistry comes, where drugs are generated, and they change the life of human being. They relieve them pain. They make the life possible on this earth, basically. Then environmental chemistry, in this subdiscipline of chemistry, we study the chemistry of air, chemistry of soil, chemistry of earth, pollution, and other phenomena that take place in the environment. Okay, so first we will have a brief discussion about the role of chemistry in everyday life. Okay, chemistry has an important contribution in our life and play a vital role in our day-to-day life. Chemistry gives us life-saving drugs. Okay, these days operations are such a big operations are possible. Surgery of brain is possible, heart transplantation is possible, kidney transplantation is possible. So many complex operations are possible, and even a person doesn't know, he doesn't feel any kind of pain. This has been possible only because of these life-saving drugs that are generated by the chemical reactions and chemistry offer us. Then chemistry in everyday life give us synthetic fibers, materials. It gives us detergents, variety of cosmetics. It provides us preservatives for our food. That is why we can deal with the scarcity of food, and food can be stored for years and years. Chemistry provides us fertilizers, which have increased production to such a large extent that no one die of starvation. This chemistry also provides us pesticides, which protects our crops and agriculture from pests and parasites. This chemistry gave us paper, glass, plastic, and beautiful paints with which we decorate our home and life. Okay, you can, these days we talk a lot that we should have a chemical-free environment or chemical-free environment, but those people who talk about this don't know that everything is made up of chemistry. Life cannot be without chemicals. Okay, we ourselves are made up of chemicals. These atoms are nothing but chemicals. Okay, our most part of our body is made up of water. Water itself is a chemical. We drink every day, we drink chemical. We drink water, that is a chemical. Ethyl alcohol, that is also a chemical. Medicines, they all are chemicals. Okay, 99% of human body is made up of 6 elements, that is oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus. They constitute our endoskeleton as well as exoskeleton. There are also some elements, chemicals that are present in trace amount, like sulfur, potassium, sodium, chlorine, magnesium. You know, sodium, that is also a metal, that is also a chemical, and it controls the whole activity of our heart, our body. Okay. Metabolism, lot of chemical reactions take place in our body. Okay, and that take place at room temperature and in biological system. Okay, and see the metabolism, we every day we eat lot of food, and within 4 to 5 hours that is converted into the product, and lot of energy is generated. All this energy is generated because of chemical reactions that take place in our body. We take animal protein, we take plant protein. Okay, this plant protein get hydrolyzed, animal protein get hydrolyzed to simple amino acids because of action of enzymes, and these enzymes carry out chemical reactions in our biological system, convert it in them into simple amino acids, which are again chemicals. Our body use these amino acids as raw material to synthesize protein of our own body. Okay, so chemistry has very important role. Enzymes that are secreted, that are that carry out these different kind of reactions. Okay, in the process of respiration, this breathing process and exchange of gases between organism and the environment. Lungs take oxygen, they release carbon dioxide. This diffusion of these gases, this phenomenon of diffusion is also based on a chemical principle. pH of our blood, that is 7.35. That pH, particular pH is maintained, and this pH play a very important role. Because of chemical reactions, the CO2 that is generated in our body, carbonic anhydrase enzyme convert this CO2 into H2CO3 by reacting with water, that is bicarbonic acid, and that maintain the pH of the blood, pH of the active tissue. In active tissue, pH is slightly acidic, and in lungs, pH is slightly basic, 7.35. Okay, so because of this pH difference, our hemoglobin is able to carry oxygen and deliver it at the active tissue site, and again take CO2 and deliver it in the lungs. When pH is basic, that is because of some chemical phenomena. In lungs, pH is slightly basic. Oxygen easily binds with the hemoglobin. Hemoglobin transport it to the active tissue where pH is acidic. When pH is acidic, only hemoglobin delivers that oxygen there and pick up CO2. Then it comes to the lung, again bind with oxygen and deliver this. So pH, that is basically chemical phenomena, and chemical reactions inside our body maintain this pH. So chemistry has this very important role. So think without, when pH is disturbed, our life is disturbed. So chemistry is taking place inside the body. Digestive juice is gastric acid that our stomach release to digest the proteins, to digest the fatty acids. That is nothing but hydrochloric acid, HCl, potassium chloride, sodium chloride. These are simply the chemicals. These gastric acid play important role to convert pepsinogen into the pepsin, which is responsible for denaturation of protein in the stomach. Okay, so chemistry has very important role in our life. Again, we are able to see, because of chemistry, some chemical reactions take place even during the process of vision. Okay, our body, our eyes contain rod cells as well as cone cells, and because of these rod and cone cells, we are able to see in the day as well as in the night. There are some birds, some animals which can see only in the daytime, or which can see only in the night time. But God has gifted us both cones and rod cells, and this chemistry, there is again chemistry in the process of vision. There is present a rhodopsin chromophore, vitamin A, that is retinal. It is 11-cis retinal. Okay, and there is also a present opsin protein. Okay, this is opsin proteins that contain free NH2 group, and 11-cis retinol have a CHO group. So a chemical reaction take place simply between this aldehyde group and NH2 group. Loss of water, this imine is formed. Okay, when light falls, this cis retinol convert into the trans retinol. Degree of conjugation increases, configuration changes, and this chemical reaction formation of imine is basically responsible in the process of vision. Now see, you have seen that ice floats on the water surface in European countries, or even in our Kashmir. Say lakes freeze, surface of the lake freeze, but still water remain in liquid form at the surface, and animals, fishes, other aquatic animals can survive at the bottom. This happens also because of chemistry. Okay, because the water molecule have different chemical structure when it is in liquid form, and it have different chemical structure when it is in ice form. When it is in solid form or ice form, one water molecule is hydrogen bonded on an average 4 water molecules, while in liquid form, one water molecule is hydrogen bonded with 3.5 water molecules. So water have different structure in ice form and in liquid form. Liquid form is more compact, and ice form, ice have more volume. There are voids due to which it have larger volume, and it is less dense. So whenever water freezes, ice remains at the top, and liquid water exists at the bottom. Okay, there is chemistry of love. Behind love also there is chemistry. We have affection to each other. We like some people, we don't like some peoples. Again, chemistry plays important role here. Okay, when emotions that we feel, okay, that we feel hate or we feel love, that is primarily because of these some neurotransmitters: love, jealousy, envy, infatuation, that all we feel. All behind all this, the base is the chemistry. Chemistry has the answer to this, why we feel such kind of this. When we fall in love, our brain suffers some changes, and certain chemicals are released. These chemicals are responsible for some specific kind of feelings at that moment of time. Okay, the sweaty palms and pounding heart during infatuation are caused by the higher level of norepinephrine. This norepinephrine is basically responsible behind this. Love is driven by the hormones oxytocin, vasopressin, endorphin. You see the structure of these hormones. Vasopressin, this is oxytocin, also known as love hormone. Okay, dopamine, norepinephrine, all these are nothing but chemicals. Because of these chemicals, whether vasopressin is released or oxytocin is released, or there is deficiency of oxytocin or vasopressin, we feel love or hate. When we fall in love, our brain releases more of dopamine and norepinephrine and pheromones, which evoke the pleasure center in our brain and leading to side effects such as increased heart rate, insomnia, intense feeling of excitement, elation, and focused attention. So basically, these chemicals, this is chemistry, nothing but the product of chemistry, output of chemistry. These are responsible behind our all kind of expressions, our feelings. Okay, in day-to-day life, we take coffee and tea. How this coffee and tea awake us? Behind this also there is chemistry. Okay, adenosine is a chemical that is present in our brain, and that is responsible for sleepiness. Adenosine that is released by when brain releases adenosine, it binds with the certain receptors. Receptors are nothing but proteins. Our body is made up of protein. Some proteins are structural protein, some are functional protein. These functional proteins are biocatalyst or enzymes or act as receptor. Okay, this adenosine, when it binds with the receptor, see, this is the chemical structure of this. When it binds with the receptor, it slows down the activity of nerve cells. Then sleep is signaled. When adenosine binds with the receptor, brain give order that you sleep. Okay, but when we take coffee, okay, this coffee contain caffeine. You can see this caffeine molecule have this structure, and it mimics this part of the adenosine. So this caffeine molecule can bind to the same receptor. When we take coffee, this caffeine can bind to the same receptor where adenosine could bind. And adenosine, when bind, it induces sleepiness. But when caffeine is induced, it don't have this effect. Rather, it evoke the pleasure center. It causes brain not to give signal for sleeping. Okay, caffeine present in the coffee changes the chemistry of brain. It blocks the action of adenosine receptor, which was supposed to bind with adenosine. Okay, caffeine does not slow down the cell's activity as adenosine would, so sleepiness is reduced. This caffeine also increases the level of dopamine in our body, and that also stimulate the pleasure areas in our brain, making us feel good. When we drink coffee, when we take tea, we feel energetic, we also feel good because of this caffeine, because it increases the dopamine level, and this dopamine level in our brain stimulate that pleasure center, we feel good. Okay, it also increases the adrenaline secretion in the body. Okay, and which keeps us awake. Every in day-to-day life, you have seen that when we cut onion, we simultaneously tears starts coming from our eyes. Okay, behind this also there is chemistry. Okay, in chemistry there are present proteins. Amino acid sulfoxide form the propenyl sulfonic acid. This propane thiol S oxide is formed when we cut the onion. There is enzyme alliinage, okay, that produce this propane thiol S oxide. This propane thiol S oxide again react with enzyme LF synthase. This LF synthase produces this H2SO4. Okay, when it comes in contact with the water, this propane thiol S oxide is a volatile gas basically. When we cut the onion, this enzyme come in contact with this S oxide, convert it into propane thiol S oxide. When this gas goes to the eyes, there is water is present, it comes in contact and it forms H2SO4. So to remove H2SO4 from eyes which have irritating phenomena, so eyes start tearing. So again there is chemistry. Now we will be discussing the application of chemistry in biological and medical science. Chemistry of, as earlier I mentioned, chemistry have given us so many drugs such as antipyretics, which lower down the temperature of the body, which are used to treat fever, like aspirin, paracetamol. In day-to-day life, we take paracetamol whenever we feel fever. We simultaneously take paracetamol, which decreases the body temperature, and we feel normal. Chemistry has given us analgesics, antiseptics, anti-cancer drugs like cisplatin. It have given us tranquilizers, which are used to treat stress, mild and severe mental disorders, mental diseases. Chemistry has given us antihistamines. These antihistamine diminishes the action of histamine released in the body and prevent allergy. Benadryl, that is used in the cough syrup, Avil 25 or Avil 50. Whenever we feel allergic, we take these medicines. Chemistry has given us antacids like cimetidine, ranitidine, which neutralize the excess of acid in the gastric juice and relief from acidity, heartburn also. Chemistry has given us anesthetics. These anesthetics makes the body insensible to the pain and other sensations. Okay. So chemistry, there are many chemical reactions also, many chemical phenomena that take place inside the body. The subdisciplines of chemistry like electrochemistry that is taking place in our body. You might have heard sodium and potassium pump. Sodium ion, potassium ion maintain the osmotic pressure of a cell, give cell a perfect shape and size. Exchange of ions take place, sodium and potassium ion. Only then neuroconduction can take place. Only then we have sensation. Okay. The sodium and potassium maintain the electrical gradient. So electrochemistry inside taking place inside our body play a very important role. Okay, gas large and diffusion large also take place in our body. Exchange of CO2 and O2, diffusion of O2 and CO2 in lungs and in alveoli of lungs that take place follow this simple chemistry principle of diffusion. Solubility, many molecules that drug dissolve in the water and they diffuse through the cell. Again, phenomena of solubility take place there. Kinetics, we take drug say in the morning, then after 12 hour again we take another drug. So it means this drug is either used by the body or it is metabolized by the body. So how rapidly are the medicine degraded inside the body, half life of a medicine, all these take place inside the body, and here we can study chemical kinetics. That is simply a part of chemical kinetics. Okay. Metal ions, that is inorganic chemistry. These metal ions inside our body play a great role. Iron is the main constituent of hemoglobin and myoglobin that help in transportation of oxygen, that help in storage of oxygen. Okay. Metal ions are very essential. Say zinc is very essential for wound healing, for smell and taste, for proper growth. Okay. Nuclear chemistry, these days, to know the functioning of a particular organ, say brain is working properly or not, kidney is properly working or not, nuclear chemistry play important role. We give isotopic and radioactive compound to the body. They go to the organ, they are absorbed by specific kind of cell, a disease cell absorb them, and by knowing that we can know whether brain is properly working or a particular organ is properly working or not. Angiography is done by which we can know without dissecting the body, we can know that heart is working or not. That we in simple language we say that dye is inserted in the body. That dye is nothing but dye is a chemical compound, that is a colored compound, or that contain a radioactive isotope that give us information whether our heart is working properly or our brain is working properly or our another major organ, say lung, is working properly or not. Like technetium 99, iodine 131 is used to know the functioning of various organs in our body. Chemicals in our food, we use a lot of chemicals in our food also. We add some preservatives, we use common salt, sugar, oil, sodium benzoate to retain the nutritive value of food for a long period of time. we make achar and other material, okay, jam, etc., by using this common salt and sugar. This salt and sugar, they are nothing but they are simple chemicals, sodium chloride or other chemical like sodium benzoate. They also enhance the taste of some food also. Artificial sweetening agents like saccharine, okay, that is 300 more times sweeter than sucrose, that can be taken by a diabetic patient also, and he have all kind of feeling, but he does not get increment in its diabetes. So chemistry have done these kind of wonders also. Chemistry also have produced chemicals that are anti-aging, that keep us young for a longer period of time. It has given us many antioxidants which prevent the process of oxidation and subsequent spoilage of food also. Even people who take more number of fruits, they remain young for a longer period of time. The reason is that fruits contain large number of antioxidants that are anti-aging, that prevent the production of singlet oxygen, triplet oxygen, harmful radical, hydroxyl radical, etc. So in fruits also these chemicals are present that actually have anti-aging phenomena, anti-aging property. Okay. NMR, XRD, these instruments have given us facility to get information about the structural biology. We can isolate DNA, we can isolate various specific type of protein, say Plasmodium falciparum protein or another proteins, HIV reverse transcriptase protein, and we can easily study the its properties, and we can easily develop a proper kind and accurate kind of drug. It has been possible because of the chemistry. uh, NMR these days also have been used in getting the structure of complex protein molecules present in our body. Application of nuclear chemistry in medical science. Okay, brain tumor location. Brain tumors are very difficult to locate, but this chemistry have made it possible. We use labeled dye that is preferentially absorbed by the cancerous cell. Normal cell does not absorb the iodine 131 or rose bengal. Then we scan the brain by simple using MRI, and we get information whether our some of the tissue is damaged, some cancerous cell is present in brain or not. So without any dissection, without opening it, we know very good information. Chemistry also have made it possible to find out the how much volume of blood is present in a patient. A patient which is going to be put to the surgeon. Surgeon first know how much of volume is present in, how much volume of the blood is present in the patient. He can get information about this, and this is because of chemistry. Application of inorganic chemistry in medical science. Inorganic chemistry mainly gives us the metal complexes. Okay, like it have given us a platinum based complex, that is a cisplatin, a anti-cancer drug that is used in treatment of testis cancer and ovarian cancer. It have also given us a gold based drug like ironafin, that is a gold phosphine complex, and that is used in treatment of various parasitic disease. Similarly, there are ruthenium and vanadium based drugs. Vanadium based drug oxo vanadium porphyrin complex that has been used to treat HIV, and these chemicals are simply inorganic compounds, inorganic complexes. Okay, one of the new field of chemistry is also nanoscience, which have attracted a lot of attention, because the chemical properties of material changes to a great extent when a material is normal material is converted to the nanomaterial. All of you know that gold is non-reactive. Its sign does not gauge. It is considered to be a noble metal. Okay, what gold as such does not dissolve in water, but when gold is converted into nanoparticle, its size is reduced between 1 to 100 nanometer. Gold is soluble in water, and it is highly reactive. It is used as a catalyst. Okay, you can see that almira that is made up of aluminium. Okay, aluminium is non-reactive and it is opaque. Okay, but when this aluminium is converted to the nanometer size, this catches fire. Material which are highly stable, which are non-reactive, they become highly active, they become highly reactive, and they have wide applications. Okay, the size of everything is reduced these days only because of nanotechnology. Okay, and it have done lot of wonders. So especially in drug discovery, drug delivery, nanoparticles are used. Nanoparticles can be used to deliver drug to a particular organ, to a particular site. Nanoparticles can be engineered in such a way that they are attracted by the specific diseased cell. Only they are attracted by the diseased cell, they go and reach to the diseased cell only, and they deliver drug there. If this way drug delivery is done, other tissue is not affected, other cells are not affected, and we will need a lower dose of any medicine. Okay, this technique reduces damage to the healthy cell in the body. Okay, nanocrystalline silver that also have antimicrobial properties and have been used in treatment of wounds, and it also have lot of applications. So I am now going to the main topic, that is drug discovery and development. Under this, we will be discussing how a drug or how a medicine is discovered, how new chemical entities, NCE, new chemical entities, how a new bioactive molecule is discovered, how a material go from table to the bench. We do a lot of chemical reaction in the lab, how these lab products becomes a medicine. We will be discussing here drug discovery, how a drug is discovered and how it is developed. Okay, this is drug discovery is basically a part of medicinal chemistry. Medicinal chemistry is basically science that deals with the discovery or design of new therapeutic agents and their development into useful medicines. Okay, so what we expect from a drug, like what we want from a medicine that I am going to have, what it should have. It should be have high efficacy, means it should be highly efficient. Okay, spectrum, I want a medicine which can, a single medicine which can treat my all illness or which can treat my single illness. Broad spectrum or narrow spectrum drug. Okay, low toxicity, I want a drug or a medicine that should have very low toxicity. You see some days that we take a medicine, then we have loose motion, we have acidity, we have heartburn or some side effects, but we want a drug that should be highly effective. We need a very small, we want a very small tablet, and that is that should not have any toxicity. We are always afraid to take large size pills. Okay, genetic factor, it should not change the genetic factor, and we want a drug that should not easily develop resistance. Okay, it should be, most importantly, the drug should have low cost and high, it should give high profit. Okay, so question comes, why we need new drugs? There are present so many drugs in the market, but still every day lot of chemical reactions are performed by the scientists, chemists in the labs, in academia, in research labs, in pharmaceutical industries. There are so many industries even within India, and in every country there are so many pharmaceutical industries. Academia also, lot of research is going on to discover new drugs. But why we need new drugs? The question is here. There are many drugs, there are many diseases for which still we don't have complete reply. Cancer, when it is in advanced stage, still we don't have any treatment. AIDS, for last 15 and 20 years we don't have a perfect treatment for AIDS. Okay, there are many viral infections, corona, we have no answer to the corona. Okay, there are certain cardiovascular disorders also for which we don't have drug in the market, or there are drugs but which are not as much effective. Okay, so we have to discover new drugs. Okay, there are some drugs but they have some side effect, so we want to discover a new drug which have no side effect. Okay, which is perfectly fine. Okay, I want a drug which is highly efficacious. There are drugs which have low efficacy to the cancer. Okay, dementia, there is drug but that is not highly efficient. Many drugs have very much side effects. When we take a medicine, sometimes we feel depression, we feel psychotic type of activity. Okay, cost of therapy is very high. In some cases you find that treatment of cancer is very, very costly. Okay, so for every individual it is not easy to afford, so to discover drugs, medicine that are very costly, which is of say 1 rupees or 5 rupees, but we don't want to, everyone cannot purchase a medicine that cost in dollars. Okay? And new drugs are also required to sustain industrial activity. Okay, pharmaceutical industry employs thousands of people, so it should give business to them. So that purpose also some drug research is going on. Okay, so in the process of drug development, how this process takes place and how much time it takes. You will be surprised to know that average time taken for a new drug to come to the market is 10 to 12 years. It takes at least 10 years for the discovery of a new drug. Okay, on an average, 10,000 to 30,000 potential substance could produce only a single molecule to the market. Okay, we start with the lakhs of final product that we think that this molecule can be a drug, but out of those thousands of molecule, lakhs of molecule, only one molecule reach to the final stage or market. The cost of bringing a new drug vary from $500 million to $2,000 million. So drug discovery process is very, very costly. Okay, you have seen that since the corona have come, since December, there are so many pharmaceutical industries throughout the world, and there are more than 200 countries. There are so many thousands of labs, highly efficient labs, and still they are not able to discover so many drugs. The reason is that discovery of a drug take a lot of time. If we want to discover a new molecule for a disease, it takes at least 10-year times. Okay, but to treat corona, efforts have been made to try the existing antiviral agents for its treatment. Okay, so we will be discussing the stages in various stages. What stages are involved in drug discovery process? When a medicine is discovered, there are different stages. First stage, we can divide it into two categories: preclinical studies and clinical studies. Okay, say I want to discover a new drug for cancer. So first, what will be done? I will constitute a research team. Okay, and we will set our objective. Say we have a group of 100 people, and we will discover an anti-cancer drug. And in anti-cancer drug also, there are so many targets, so many proteins through which we can treat it. We have to be more specific. We have to set our objective that we will be targeting this protein, we will be targeting this receptor, and we will make a medicine against this. So this group of 100 people then will carry out the synthesis of several novel molecules. We will synthesize thousands of molecules. How we will synthesize? First, we gain knowledge from the literature. We see which kind of traditionally natural products are bioactive. in a natural product that is isolated from the plant, we see what is inactive, what is active ingredient in that natural product. We will try to gain knowledge from them, or we gain knowledge from the computational studies by docking studies. Then we will design, first we will design the molecule, and we will synthesize thousands of molecule by different variation in the different part. Okay, then we will go for its in vitro testing. We isolate the diseased cell, we apply that drug or that compound or that a molecule on that, and we will study the in vitro properties, whether the molecules which are in vitro highly active will be further going to the in vivo stage. In vivo means inside the living organism, say mice or rat or monkey. We will go then for the first apply on the rats and mouse. Then we will go to the higher animals which have properties similar to human beings. Okay, chemicals will be tested for efficacy and safety in the test tubes and in the lower animals. Okay, from this we could found a highly active molecule which in very low amount is highly effective, can kill the cancer cell, can treat the cancer cell. That is study in the animals, lower animals, rats and mouse. Then up to this stage we had synthesized molecule in gram scale, say 1 gram or 2 gram scale or 10 gram scale. Then we will go for its process development. We need this molecule in tons and quintals in kgs, so a process will be developed. Sometimes it happens that some reactions are working at the small scale when carrying out at gram scale, but it does not work at the higher scale. So first, because at the later stage, if a molecule becomes a drug, it is active, we will be needing it in large quantity, in quintal, in ton, okay, for the treatment of disease. So we will need a process, large scale synthesis of this drug molecule, and we have to find out its proper formulation, how we will deliver it, whether it will be delivered orally or intravenously or intramuscularly, how it will be delivered, and we have to study its stability. Here we will also study the drug toxicity. Okay, whether a molecule that we have synthesized, it is a very good drug, okay, it treats that disease, say it kills the cancer cells, but we have to see that if it is killing the normal cell or not. So toxicity study have also to be done. Okay, then the company files the IND application, investigational new drug application. We have to apply for it. Okay, that we have discovered a new drug. Okay, it is working in the lower animals, it is non-toxic, and we want to use it for human beings. So first clinical studies will be carried out. So second part starts here. This whole part was the pre-clinical study. Now we goes to the clinical study. A drug molecule that have been synthesized, now we will first investigate on the human beings. Okay, there are 3 different phases: phase 1 clinical trial, phase 2 clinical trial, and phase 3 clinical trial. If in all these clinical trials, if a molecule is found to be active, that it is killing the cancer cell, or it is treating the disease, it killing the virus, or it is killing the bacteria, then we will apply for its approval to the FDA. FDA is USA based Food and Drug Administration. Okay, all the countries of the world that prepare a drug, they have to take approval from the FDA that we have this drug, it is highly efficacious, it is low cost, it is useful, it will treat this disease, and we want to launch it into the US market or in our country. So they have to take their approval from the FDA. If FDA give approval, then drug goes to the market. Okay, now you will see why it takes so many years and why the cost is so much. See, in initially we start from lakhs or thousands of bioactive molecules. When we screen them in vitro, we end up with 5,000 to 10,000 of compounds, and it takes 3 to 6 years, because we have to again repeat those results. Those results should be repeatable, they must be authentic, we have to reinvestigate them several times. Okay, then we go for preclinical studies in small animals, in vitro study, in vivo study. Okay, then we go for their toxicological study, we go for their formulation, how the drug will be delivered. It will be delivered orally or intravenously or intramuscularly. This preclinical, up to this clinical stage, it take around 6 years. Okay, then out of say lakhs of molecule from whom we were started, around 250 molecules cross the preclinical stage. When we go to the clinical stage, out of those lakhs of molecule, only 5 remains, because many molecules found to show toxicity or some side effect, or they are unstable, they cannot be delivered. Okay, then they goes to the phase 1, where we applied phase 1 clinical trial, where we try that drug molecule over 200 to 220 to 100 peoples, then 100 to 500 peoples, and then on a large group of peoples. Or in this way, hardly 1 or 2 molecule reaches to the final stage for approval of FDA. This process also take again 6 to 7 years. FDA approves that drug after full re-investigation, and it may take again 2 years. Okay, so overall you will find that a drug to be discovered take around 10 to 12 years. Okay, again I have represented this drug discovery and development process. Okay, first we identify a disease that say I want to work in the field of cancer. We want to, because cancer is lot in Punjab area, in Bathinda region, in Malwa region. So I want to work on, say, anti-cancer drug. I want to develop a drug that can treat cancer. So first we identify a disease. Then we isolate a protein that is involved in the disease. We identified that this protein is responsible for cancer. Okay. Then we synthesize large number of molecules, or alternate way, we can target this protein with hypothetical molecules that we designed hypothetically. Okay, this preclinical study and this protein isolation study takes over 5 to 6 years. Then we go to the small animals to find the effectiveness of a drug, to find whether a drug is toxic or not. Okay, in small animals, rat, first it is attempted in rat and mouse, then we goes to the monkey. Okay, if drug is efficacious in these animals showing no toxicity, we carry out scale up. We synthesize that drug from gram to kilogram scale in quintal of scale. Then we go for its formulation mean how we will deliver this drug, whether that molecule will be given orally or intravenously in the form of injection, which way it will be given. Then we file IND. IND means investigational new drug. The company or a group of people will file IND to the government that we have investigated a new drug. We want to go for clinical studies. We want to test this drug in the human beings. Please give us permission. Okay. So in that case, we go to the human clinical trials, and it have phase 1, phase 2, and phase 3. This process takes 2 to 10 years because we have to observe the side effect of those drugs also. Okay. Then we file NDA, new drug application, to the FDA, and it may take up to 2 to 3 years from FDA, because passing through FDA is a very stringent process, and it takes a lot of time because they study very closely that drug will not have any side effect in the market, or it will not cause any disaster. Why FDA takes so much of time? Behind this also there are reasons. There have been thalidomide tragedy. Okay, when woman is pregnant, they have the problem that they have early sickness. Okay, they are in the early morning, they feel sick, they feel fever, or some other kind of problems, they don't feel good. So thalidomide was a drug that was given to those women. They felt very good. Okay, but when the childs were born, they were limbless. The drug shows the genotoxicity, and a large number of childs throughout the world were born with so many problems. They were not having hands, or some were not having, say, one leg or two leg or fingers. All were having some abnormality. So FDA, that is Food and Drug Administration Agency, must have to see very carefully that this drug is not having any side effect. It watches those side effects closely. Okay, it interacts with those people that have gone human clinical trials. Okay, I have again presented the same thing. Okay, as I mentioned, a drug discovery process take 10 to 12 years. Okay, but these days the technology has come through which this time has been reduced to some extent. Okay, like genomics, proteomics, okay, high throughput screening, where we can screen around 1 lakh of molecule in a single day. Okay, which earlier used to take 2 to 3 years. It have reduced time significantly. We can carry out virtual screening. Okay, with virtual screening, we hypothetically synthesize we design a molecule and test it against the isolated protein or target. Okay, this way some time has been reduced for the development of the drugs. Okay, for drug discovery, there have been two approaches: traditional approach and the latest approach. In traditional approach, first rapid screening of compounds was done. Say, first large number of organic molecules were synthesized in the lab by chemical reactions. Then we screen them in vitro and in vivo. Say we screened 1000 molecules. Out of those, we found 10 molecules that were very active. Those molecules were very active, but we don't know whether these molecules will become drug or not, they will be toxic or not. So we call them lead compound. Okay, these molecules are highly active, we call them lead compound. Then we modify these compounds further. We carry out structure activity relationship, that by installing that particular substituent, its activity is increased or decreased. That is carried out, and we find a molecule with improved activity. Okay, then we find out its site of action, how it will be acting. We discuss its toxicological study in cells, animals, small animals. Then we go for human clinical trials, and a drug will become. Okay, so this path is much more lengthy, will take minimum 12 to 15 years. Okay, but in 21st century, we have more technology, and a alternate path is followed. We know that inside the body there is disease because of some problem. That problem is in the protein or a receptor, or in that organ there is present some protein or receptor, because there are only proteins that are functional inside our body. Okay, there are also carbohydrate, there are also receptor also, but mainly proteins are there which act as receptors, or which are the targets. So we can isolate that protein. We isolate that protein, we find out its 3D structure. Okay, we have computational structure. Then we can design molecule according to the active site present in that protein. We hypothetically design molecules, and we study, we carry out their docking studies or QSAR studies, and we rationally design a molecule. Now the molecule is designed, then we will go for its synthesis. Okay, now we are going for synthesis. So in this way, the time that was required for the synthesis of molecule is decreased significantly. Okay, these synthesized molecule that were rationally designed, they were designed with some logic, because we have seen that in outside the cell, this molecule is interacting with this protein. So inside the biological system also it should interact, but there is no guarantee that it will really interact. Okay. So synthesis of then those designed molecule that were anticipated to be active, their synthesis will be carried out. Then we will assess their inhibitory activity, to what extent they are biologically active. Then we again will find a lead molecule. We will carry out structure activity relationship to find out a more bioactive molecule. Then we will carry out its toxicological studies in isolated cells and in animals, say in rat, mouse, and monkey, because we must be sure that this molecule will not be toxic in the human beings. So lot of studies carried out at this stage in small animals. Then we go for the clinical studies in human beings, and again there are 3 phases which we will discuss later. Okay. How this cost is so much? Okay. By using this 21st century approach, we have, say, target molecule or lead compounds around, we will start with around 2000 molecules. The cost of their synthesis will be around $100 million. Then when we carry out their in vitro activity or in vivo activity, in that case around $0.5 million will be required. And during this stage many molecules will be screened out. We will found that out of 2000 molecules, only 100 molecules are really active and non-toxic. Okay. When we carry out preclinical studies in first phase, many molecules go out. Out of 100, we will have only 20 in phase 1. Then in phase 2, out of 20, we will be, say, reduced to 3 to 4 molecule. And molecule which crosses the phase 3 also and goes for FDA approval will be 1 or 2 molecules. And in this process again it takes $50 million cost. Then we go for marketing purpose. So you can see that in the path of drug development involve first designing of a molecule. We design molecule that is supposed to be biologically active. By using computer we can design molecule, or by taking information from the natural product we can design molecule. First molecule is designed in the lab, then we will go for synthesis of molecule. Then say 2000 or 5000 molecules or analogs will be synthesized. Those 2000 molecules then will be tested for in vitro screening first, then in vivo screening in small animals, then higher animals. Okay. Then toxicological studies is carried out, formulation study is carried out, then go for the clinical trials. And out of thousands of molecules, we finally reach to 1 or 2 molecule that crosses the clinical studies. And in many cases, even not a single molecule crosses this clinical study and fail it. In that case, that a billion-dollar company go bankrupt also. Okay. So how this target identification or protein identification is done? Okay, which protein is basically responsible for cancer, or which protein or DNA or RNA which is responsible for the disease? Okay. Now the latest technologies are genomics, bioinformatics that are used for the screening of targets. Okay. By using these techniques we can identify the target. Okay. And we can use computational tools for drug design, chemoinformatics, through which we can design compound libraries. Bioinformatics, we get information about the genome libraries. Okay. Then we get, by using structural biology, we get protein structure determination. Then we carry out docking studies. We see the interaction of our designed molecule with the protein molecule, isolated protein. Then we carry out computational chemistry also, CADD, computer-aided drug design, SAR, structure activity relationship, QSAR studies are carried out, so that we have molecule that is very, very rationally designed and there are very good chance that it will become a drug molecule. While developing a drug molecule, a rule that is known as Lipinski rule is followed. This Lipinski rule is followed based on the observations, and it is a hypothesis. Till date, so many drugs have been discovered. So generally, it has been found that molecules which have low molecular weight, which have some specific number of hydroxyl group, OH group, or NH2 group, are biologically active. So on the basis of that, Lipinski formulated a rule that is known as Lipinski rule of 5. Okay. So as per Lipinski rule, not more than 5 hydrogen bond donors should be in a drug molecule. That if a molecule have less than 5 NH2 group or OH group, that molecule will have good property to become a drug. Similarly, the molecule or that drug molecule should have less than 10 hydrogen bond acceptor. Okay, like tertiary amine. Tertiary amine can accept H positive. It is hydrogen acceptor. Okay, it should not have more than 10 tertiary nitrogens or secondary oxygens. Okay, like ether group. It should not have more than 10 hydrogen bond acceptor. Okay, the molecular weight should not be more than 500 Dalton. Okay, and log p value of that molecule should be less than 5. So you can say that in here is also 5, here is 10, here is 500, here is 5. All are divisible with 5. So it is known as Lipinski rule of 5. Actually, there are 4 rules, but all 4 rules there is digit which is divisible with 5. So called as Lipinski rule of 5. Okay, I am repeating again. A molecule have good chance to become a drug if it have less than 5 hydrogen bond donor, less than 10 hydrogen bond acceptors, molecular weight of that molecule that we have synthesized, if its molecular weight is less than 500 Dalton, it will have good chance. And log p value should be less than 5. If log p value is less than 5, in that case, a molecule can easily cross the membrane of a cell. Okay. So it will have good permeability and it have very good chance to become a drug. Okay, when we have synthesized drug molecule, okay, we have carried out its in vitro testing and in vivo testing. Then we go for drug metabolism and pharmacokinetic study. We must be know that what will be the fate of drug that we have taken. Say I have taken a crocin medicine. What will happen when it go inside my body? How this molecule will be degraded? What will become this molecule? Whether will bind with which protein, or how this molecule will be absorbed? How much of it will be absorbed? Say I have taken 500 mg capsule. Okay, whether 500, all of 500 is absorbed into the blood, or just half is absorbed. How much is absorbed? Which is absorbed mean which goes to the blood. After going to the blood, what will happen to it? Okay, so all these part comes into pharmacokinetic study. We study pharmacokinetics, drug concentration in biological metrics, that we have taken drug, how much of it goes to the brain, how much goes to the plasma. Okay, identification of drug metabolite means a drug after going to the body, whether it get fragmented, some bond carbon bond cleavage to take place, or molecule divides into 2 parts, or some what fragments are actually formed. Okay, and then we study the absorption, distribution, metabolism, elimination studies. Okay, that how much of drug is absorbed into the blood, how it is distributed, where, in which organ of the body it goes, whether it goes to the targeted protein or not, whether it goes to the site for which it was formed or not, how it is metabolized. what are the end products, and how it is excreted out of the body. That is very important. Okay, it is excreted through the kidney, whether it damages the kidney or not damages the kidney. So all those we call this as ADME study, absorption, distribution, metabolism and elimination studies, that is carried out under this pharmacokinetic study. We also use biomarkers, okay, for quantification of drug. Okay, then after this study we have to find out the route of administration of the drug, whether which way the drug will be given. Lot of effort are made to make a drug orally administrable, because people likes to take drug orally. No one wants it to be injected into the body intramuscularly or intravenously, because that is a painful process. But depending upon the drug molecule, whether a molecule is highly stable, it will be able to tolerate pH, very low pH of stomach, where pH is around 2 to 3. It will be able to tolerate that highly acidic pH and then highly basic pH. Where if a molecule is stable, it can tolerate highly basic as well as highly acidic pH. Okay, only those molecules can be delivered orally. But some molecules have some sensitive functional group, and if we take them orally, this HCl can carry out its hydrolysis. Okay, drug is metabolized and it is no more active. Okay, similarly in basic medium also drug may degrade. In that case, those drug does not reach to the blood in the same form in which it was formed. So to deliver it into the same form, purpose is to deliver into the blood. Okay, with drug we take orally, it is absorbed. Absorbed mean part of the drug that goes into the blood. Okay, so various routes, like whether drug will be administered intramuscularly or subcutaneously or intravenously. Okay, so that is depending upon the stability of that drug, route of administration is carried out, but efforts are made to make it orally active, orally bioavailable. Okay, we have again discussed pharmacokinetics. Okay, pharmacokinetics describes how the body affects a specific drug after administration. Okay, first we study how a drug interacts with the body, how it is absorbed, to which organ it goes, what drug does to the body. Then we study what body does to the drug. Okay, and again ADME study is carried out. Okay, then in vivo pharmacology is come into play. In this case, dose is defined. Okay, dose optimization is carried out, that this dose will be effective dose, whether a kerosene tablet of 100 mg will be sufficient, or it will be 500 mg or 1000 mg. Okay, dose is defined. LD50 is carried out. What is the lethal dose? We cannot give a drug in large amount also, a medicine in large amount also, because if given in large amount, it will also be toxic. So what is the highest dose that can be given, what is the lowest dose that can be given, and what is the most effective dose that can be given? So during this in vivo pharmacology, this is all carried out. Then during toxicology, we carried out the various parameters related to drug safety, whether which quantity of drug is safe, which is lethal. Okay, drug can also treat the disease, it can also kill a person if it is given in higher quantity. Okay, LD50 is determined. Evaluation of organ toxicity is carried out. Drug safety evaluation is carried out, and risk assessment is carried out. Okay, and all this toxicological study is carried out as per international guidelines, WHO guidelines, ICH guidelines, or US FDA guidelines are followed. Okay, then now we have synthesized a molecule that have crossed preclinical studies. Okay, the molecule is highly active. It is not having any toxicity in vivo, in vivo, in lower organisms. No toxic, highly efficient. So we will now like to try in the human beings. Okay. So for this purpose, we have to take approval from the government, from the agency, international agency, that we have investigated a new drug, and we have to file IND program, that investigational new drug, that we have discovered a new drug. We want to test this drug in the human beings. We want to go for the clinical trials. We want to try in human objects. Okay, it means a IND program involves the permission to ship an experimental drug across states before marketing it. Okay, in this case, FDA reviews the drug application for the safety, to assure that research project will not be subjected to unreasonable risk. Okay, that drug is not risky. It will check all the parameters, that drug is very, very safe. Then it will be allowed, then only then application will be approved for testing in human beings. That also in 3 different stages: phase 1, phase 2, and phase 3. Okay, in phase 1 clinical trial, okay, I am exceeding the time, I'm sorry. Phase 1 clinical trial that begins after 30 days of approval. Drug is first given to the healthy volunteers. Why first drug is given to the healthy volunteers, healthy human beings? Because first we want to test that if a human being, this does not have cancer, this does not have any disease, but if he take that medicine that is for cancer, that is for a disease, whether in normal human beings will not be affected. First we will check the toxicity of the drug. So it is given to the human beings, and only small number of human beings. Maximum size will be 100 peoples. Okay, drug is given to the healthy volunteers. Duration could be 1 month to 1 year. And during this phase 1 clinical trial, the study is carried out about drug absorption and metabolism in human, that how much drug is absorbed, because earlier we had investigated in the lower animals only. Now we will test it, absorption of drug and metabolism of drug in human beings. Sometimes a drug is very active in the lower organism, rat or mouse, but it is not active in human beings. That also happens, and inactual happens, because out of say 100 molecules, only 20 molecules cross phase 1, the toxicity at this phase 1 clinical trial. During this stage, we also study the effect of drug on the organ and tissue, whether there is some side effect of different doses. During this case, this study, we also investigate that which dose of the drug, whether 100 mg is efficient, or 5 mg, or 200 mg, or 500 mg is effective dose. That is also determined, and this stage also take years, 1 to 2 years. Here, from phase 1, effective early evidence on effectiveness of drug are achieved. Then we proceed to the second stage, or phase 2 clinical trial. In this case, the drug molecules which don't show any toxicity and will be given to the real patients, but small number of patients. Okay, small number of patients. In this case, drug is given to the patient volunteers. Sometimes these patients are paid also. Okay, and the duration of this study is 1 to 2 years. Why it take 1 to 2 years, though the drug is given say for 1 month only? The reason is that to show the side effect in patient, whether drug is treating the disease permanently or it is recurring after some days. So after giving even dose for 1 month, we have to keep that person under investigation for say 1 or 2 years. The disease is not recurring, or say resistance is not coming. Okay, and it could cost up to $100 million, because these volunteers have to be paid. They have to keep watch. They have to provide them so many kind of facility. They have to keep them in a controlled environment. Okay, from phase 2 clinical studies, we get information about drug effectiveness in treating the disease. In phase 1, we had got information about the effectiveness of a drug, toxicity of a drug, not effectiveness but toxicity, drug is toxic or not. But here we will find out that how much effective is this drug is. Okay, we will also get information about the short-term side effects of drug in patients, whether some effective molecules have some side effect or not in a short period of time. In this case, about 1/3 of molecule rarely survive, and they goes to the phase 3 clinical trials. Okay, in this case, for going to the phase 3 clinical trial, this is basically the most important step. FDA is consulted before beginning for the phase 3 clinical trial, because it is carried out in large number of peoples. And in this case, FDA persons are also present to see that what are the actual results. Okay, drug is given to the patient volunteers, large number of patients. Okay, and the duration of drug could vary from 3 years to the 4 years. Okay, and it could cost up to $500 million. From this phase 3 clinical study, we get information about safety of the drug molecule, how much beneficial drug is, and how much is the risk, whether benefits are more or risks are more. If a drug is highly beneficial but it has some small side effects, small toxicity, it can be neglected. Okay, in this case, long-term side effect in patient are also investigated. Okay, this study take 4 years, so it takes lot of time, because we have to keep those patients under controlled condition. We have to see the side effect. Sometime side effect appears after 1 year or 2 years, kidney is damaged or lung is damaged or heart BP is increased. So after 1 or 2 years, we have to keep whole history of the patient for 3 to 4 years. That is why $500 million is the cost. Okay, then when a drug molecule is very effective in human beings also, it is no toxic in healthy person, it is non-toxic in patients also, and it is highly efficacious, it treats the disease in a very good manner, then it goes for the approval of FDA. Okay, and we add a application that is known as new drug application to the FDA for approval. Okay, and we provide lot of evidences to the FDA that this drug is effective. We have to keep the during clinical studies, everything is recorded. Patient is kept under record, whether side effects are there or not there. So full evidence are provided to the FDA that this drug is very, very safe and it is very effective. It have more benefits and it have no risk or very less risk. Proposed labeling is appropriate. ड्रग के ऊपर जो लिखा है वही ड्रग के अंदर भी है. The chemical structure that is labeled on the drug is also same inside the drug. The drug is a single enantiomer or mixture of enantiomer or racemic, or it is 99% pure, or it is 100% pure, or it is 99.99% pure. Everything have to be mentioned when we are going for approval from the FDA. Okay, then drug is launched into the market. Okay, and after launching into the market, again it is drug is kept, investigation is carried out whether patient are not getting any side effect, or it is working on a wide range of patients, working in having in different countries or different ecological areas. Okay, and used in different class of patient also, like children, old people, young people. It is kept under control for 3 to 4 years so that side effect does not appear later. Okay, and with that I would like to finish my presentation, and thanks to all of you for giving your time, and I'm sorry for exceeding the time limit. Hello.
Yes, sir.
Yes, sir.
Okay, I'm sorry, I exceeded a lot of time, but I could
No,
not know.
sir. You are within the time, sir.
Yes.
Okay.
You are within the time. I will call upon now Gopinath sir for the question answer session. Gopinath sir.
Yes. So, am I audible?
Yes, sir.
Okay. So we got a few questions, couple of questions we got, but it's like similar kind of things. So I'll compile and send it. So it's like first question we have, what is the difference we get when we use NMR 400 and NMR 800 for a biological sample?
Okay, in both cases, chemical shift does not change for a signal. Chemical shift of a signal does not change, but we get a much more resolution in case of 800 NMR. Okay, 800 NMR is generally used for 600, 800 NMR is used for study of highly complex molecules like proteins, where there are so much large number of proteins, where there is so much complexity, high coupling, and so many chiral center. In that case, it is used. We get very separate peaks. Resolution is increased. Okay, so that is the only difference. Otherwise, chemical shift remains the same whether we carry out a 200 or 800 or 400 NMR. And these days, NMR is actually used for study of proteins, drug-protein interaction also. And say in few years back also, Nobel Prize was also given for application of NMR in structural elucidation of biomolecules.
Okay. So we have second question. That is, what is the difference between normal drug discovery process and vaccine discovery process, like timing and we can see in COVID-19, it is taken 8 to 9 months.
Yeah.
So, and in normal drug discovery, it is taking around 8 to 14 years. So, like so many questions on this. So, I'm compiling this one. So, what is the difference in vaccine discovery process and normal drug discovery process?
In normal drug discovery process, as I mentioned, we discover a totally new molecule. Okay, in totally discovering a new molecule, we have to synthesize thousands of molecules, even lakhs of molecules sometimes. And when we are designing earlier, we isolate the protein. In isolating the protein or defining or find out which is the actual target for this disease, which is the actual receptor, what is the actual cause of this disease, this protein is responsible or this receptor is responsible. We isolate those molecules, then we validate that target. Okay, then we carry out computational study. Okay, and then we design molecule. After designing molecule, we carry out this computational study. Okay, after this rational designing, those designed molecule have to be synthesized, and they have to be synthesized with all possible say structural diversity in that molecule, with the keeping in mind the Lipinski rule and so many parameters. So this molecule synthesis process take itself 3 to 4 years or 2 to 3 years. Protein isolation and target validation, this process itself like 2 to 3 years. Okay, then there is in vitro study, then in vivo study in small animals, then we carry out the toxicological study in small animals. So this again take 2 to 3 years. Okay, so number of molecule is decreased. Okay, at every step. Then we go to the preclinical studies, phase 1, phase 2, phase 3. At every stage we need 1 to 2 to 3 years of time. So this process is highly time taking, and a lot of money have to be invested in this process. Okay, but in this vaccine process, the route is different. Okay, so totally in this case we don't carry out this synthesis. Okay, we like in case of corona, we already known molecules were attempted already, like hydroxychloroquine, that is already known in the market for so many years, discovered for so many time. Are not a new molecule is synthesized and discovered. Okay, already existing antiviral agents have been used. Okay, or and in vaccine actually the patient antibodies or that is used, so that is totally different. These two things are totally different, so it is very less time taking process in case of vaccination.
Okay. Next question is how artificial intelligence and machine learning are helping to find COVID-19 drug discovery, or means precise role of artificial intelligence and machine learning in COVID-19.
Artificial intelligence see देखिए confirmation about whether it is COVID-19 positive or not only by this replication of protein only that is present in the blood we can carry out, we can get information, but and that is the best way, actually authentic way. Artificial intelligence can also help to in detection. Okay, but authenticity again remains the matter.
Okay. So next question is what is generic medicine? What are the process of production, transmission, and distribution?
Generic
So
medicine
distribution part we can leave it. What is generic medicine we can ask?
Generic medicine, see paracetamol. Okay, there are the actual in a disease a molecule, particle molecule, say simple, I take the example of toluene molecule. All of you know that toluene molecule is responsible for the treatment of a particular disease. Okay, so that will be the medicine actually responsible for it. It can be synthesized through different ways. Okay, generic medicine are generally low cost medicines also, and what I say, I am the real salt that is responsible for activeness of a drug, that is a generic part of that.
Okay. And one more question we have, like, what is significance of RF value of organic compounds in medicinal chemistry?
RF value. Okay,
Yeah.
RF value tells about the molecule, whether it is a polar molecule or non-polar molecule, about the purity of a drug or purity of a molecule, if it have single spot and molecule is pure. Okay, RF is low if depend upon the say absorbent we are using, say it is of polar nature. Okay, molecule which have high value of RF, okay, that is non-polar. If it have low, it is polar. So RF mainly give information about polar molecule or non-polar molecule, and that also further depend upon the polarity of a solvent and the polarity of say TLC plate that we are using, whether it is alumina TLC plate or silica gel TLC plate, or silica is again basic, sorry, silica, not alumina is basic alumina or acidic alumina. So RF give information about generally polarity of a molecule. Molecule is polar or it is non-polar or less polar.
Okay. Thank you, sir. We have a lot of questions, but for time concern, we are not taking any further questions. So, Himadri, sir, can you please proceed?
Yes, sir.
Thank you, sir. Himadri, sir, you can continue the session.
Okay. Okay. So thank you very much, Dr. Virendra sir, for such an illuminating session, and I'm very sure that all the participants are feeling very enlightened, and especially this question answer session was an addition to what we already received from you. So thank you very much, sir. We are very privileged to have this. So we are at the end of this session today formally. So I invite Mr. Gopinath Gorai, the head of the Department of Chemistry at St. Xavier's College, to propose a formal vote of thanks. So Gopi sir, over to you.
That's my privilege. And first of all, sorry for the inconvenience caused. Whatever we have, like technical glitch, we are having various technical obstacles, and also that can be possible because face to face is something different, and over the internet it's something different. So in internet we don't have any control. So anyway, we have to move on. We gain the knowledge. So now it's coming to the end, and that is the very difficult part, which we have to say vote of thanks. Anyway, we have to carry on. So it is very difficult to propose a formal vote of thanks when you have to thank a person for things which can never be adequately appreciated or regarded by verbal terms of regard only. This is one such memorable occasion when we had the great pleasure of having such eminent personalities amidst us who blessed us with their gems of profound wisdom that are going to be treasured for a lifetime. I would attempt to express my sincerest gratitude for them. First of all, I thank Almighty for having provided us with this wonderful opportunity of organizing a webinar that led us towards newer path of enlightenment. I express my sincere gratitude for our Honorable Vice Chancellor, Madam, from the core of my heart for taking out precious time from her extremely busy schedule and being with us, blessing and inspiring us with her noble words of motivation and chemical knowledge. Thank you, ma'am. We will keep our words in our hearts forever. I express my profound gratitude to our chief speaker of this webinar, Dr. Virender Singh sir, who enlightened us so immensely with his wonderful presentation and his scholarly lecture. I am certain all the participants have been hugely benefited and introduced to a new sphere of learning after today's session. After today's session, they will be learning, like they will be more curious about COVID-19, how the drug is getting discovered for COVID-19, how previously it was. So the view will change. So again, sir has very kind to take out some time from his busy schedule and be with us today to guide us with his profound wisdom and experiences. I thank our principal and patron for this webinar, Reverend Father Dr. Stephen Raj, and the IQAC coordinator, Reverend Father Dr. David Raj, both who have stood with us constantly and strong pillars and illuminating guides. Without their constant support and guidance, this event could never been possible. I thank you, sir. I thank all the participants who joined our Xavierian family today and made this event a successful one. Last but not the least, my heartfelt thanks and regards for the organizing committee and our co-convener who played a crucial role with their technical assistance and cooperation towards the successful management of this program. St. Xavier's College Maharo encourages and looks forward to organize more such academic events with its aim of providing a novel platform for the academic fraternity, going by its motto, to enlighten and to empower. With these words, I, Gopinath Garai, take your leave. Take care, stay safe. Lord bless us all. Thank you. Thank you, sir.
Thank you, sir.
Thank you, sir.
With this word, we end the session here. Thank you, everyone.
Yeah, thank you. Thank you all.
Thank you, sir. Thank you all. So participants can check the chat box. The feedback link has been provided there, and the instructions to download the certificates have been provided by Mr. Amresh. So thank you very much for being with us. We had a very brilliant time today.